Okay, this is the combined gas law, which when you look at it, it has Boyle's law, Charles's law, and Gay-Lussac's law as part of it. So, we use this when nothing is held constant. So, we go about our same pattern as we've done before. We're going to make our list. 75 liters. And that's V1. 27 degrees Celsius. 27 degrees Celsius, there's our T1. And we have to add 273 so that we're using Kelvin. 733 millimeters of mercury is our P1. What will be the volume? So there's our unknown, volume 2. So we need a T2 and a P2. At first glance, it doesn't look as if we have been given them. However, right there, those three letters, we had STP earlier in our notes. It stands for standard temperature and pressure. And they come with actual values. Standard temperature is 0 degrees Celsius or 273 Kelvin. Standard pressure is 1 atmosphere or 760 millimeters of mercury, depending on what unit you need. We need the millimeters of mercury and the Kelvin. So now we have our equation. V2 is our unknown, so we have to do the algebra to get rid of it. So we've got to divide both sides by P2. So here on the right it cancels. We've got to multiply both sides by T2. So on the right it cancels. And now we can plug in. 273 Kelvin. Times 733 millimeters of mercury times 75 liters divided by 760 millimeters of mercury and 300 Kelvin. So Kelvin cancels, millimeters of mercury cancels, so we're left with units of liters, which makes sense for volume. Now, when you're putting this in your calculator, times before anything that's on the top and divide anything that's on the bottom. So as I was typing this into my calculator, I would say 273 times 733 times 75 divided by 760 divided by 300. And you get 65.82532. And it keeps going, but we need to round it to 66 liters, because we're only allowed to Only allowed 2 significant figures. So pause and try this one, and then play again to get the answer. Scuba diver 40 feet below the ocean surface. Yeah, that's nice, but that doesn't come into my problem. 50 milliliters. There we go. That's a volume. First one I get to. A pressure of 3 atmospheres. So there's my P1. 8 degrees Celsius. There's my T1, but I can't use Celsius, so I need to make it Kelvin. 281 Kelvin. What is the pressure? So there's my unknown. If the gas expands to 150 milliliters, so there's my V2 at a temperature of 37 degrees Celsius, which is T2, add 273, and that gives us 310 Kelvin, normal body temperature. There's our equation. P2s are unknown. So times T2, cancels on the right. Divide by V2, it cancels on the right. Plug in our numbers. Alright, so 310 times 3 times 50 divided by 150 divided by 281 gives us 1.10320. And it keeps going. Kelvin cancels, milliliters cancel, so we're left with atmospheres, and significant digits, we're allowed 3. So there's our answer.